Hello everyone, let us discuss about the LeetCode problem 3351, sum of good subsequences. So we are given with a vector of integers nums and we need to find the sum of all possible good subsequences of nums. So a good subsequence is said to be having the consecutive elements absolute difference as 1. That means 1, 2, 3, 2. This subsequence is having the consecutive elements are having absolute difference as 1. So we can say it as a good subsequence. So we are given with an example 1, 2, 1. So we need to remember that a element in a subsequence, only one element in a subsequence is always a good subsequence. So for 1 we are having a good subsequence 1. For 2 we are having a good subsequence 2. For 1 we are having another good subsequence 1. Now a subsequence will be said that the previous elements will be having in the nums. That means if 2 we are having a 2, now we need to take only the elements which are before 2. That means 1, 2, and we need to cross check whether it is a good subsequence or not. 1, 2 is having a absolute difference of 1. So we can say it as 1, 2 is a good subsequence as it is having absolute difference of 1. So we are at 1. Now we have 2 and 1 here, and we can say 2, 1 is also a good subsequence. If we see this subarray, 2, 1 is also a good subsequence. So we can write 2, 1 as a good subsequence. But we cannot say 1, 1 as a good subsequence because 1, 1 absolute difference will be 0. So it will not be a good subsequence as it should be the absolute difference should be 1. It is not a good subsequence. But 1, 2, 1 is a good subsequence because 1 and 2 is having absolute difference of 1, and then 2, 1 is having an absolute difference of 1. So we can say 1, 2, 1 is a good subsequence. So we are having at this point the sum of the good subsequences at nums of 0. That means at 1 we are having the sum as 1. Now at 2 we are having, so now the sum till 1 is 1. If we mark 0, 1, 2 as indices of this array and we keep the sum at every index, for 1 we will get 1 as a sum. Now for index 1 we are having 2 plus 1, 3 plus 2 as 5. Now at index 2 we are again having 1 as another element which we already had in the last. So it is better. So for example, if we are having 1, 2, 1, 2 and so on, we are creating a number of index. For example, if it is a size of 100, we need to have a size of 100 a size of 100 blocks. So it will waste our memory. So instead of this, if we have stored one element 1 sum and element 2 sum, it will be better. Instead of storing 100 elements, 100 indices sum, it is better to store the elements sum. So at 1 we are going to have the sum of 1 is initially 0, but at index 0 we got 1 and sum of 2. At this point we got 5 as the sum, and at index 2 we are again having 1. So at this point we got the sum as 1 plus 2, 3 plus 1, 4 plus 1, 5 plus 2, 7 plus 1, 8. So the sum at this index 2, we are having one's sum is 8. So previously the sum of 1 is 1. Now it has increased and now it is 8. So here we are getting 8 and here we are getting 1. So 1 should be added. So this will be the sum of 1. Sum of 1 will be 1 plus 8, but sum of 2 will be 5. So the total sum will be 14. The sum of all the subsequences here will be 14 now. Now let us look at another example. 191 3 10 2 comma 8. So if we carefully observe, 1 is a subsequence, and for 9 is a subsequence. For 1 is a subsequence, 3 is a subsequence, 10 is a subsequence, 2 is a subsequence, 8 is a subsequence. Now, to know the consecutive elements or the difference of the consecutive elements should be 1, we need to check the previous element and the next element. That means if we are having 7, we need to look for 6, and we need to look for 8 if we have 6 or 8 previously before 7 has come in the array. So for 3 we have 3 as a subsequence, for 10 we have 10 as a subsequence, for 2 we are having 2 as a subsequence, for 8 we are having 8 as a subsequence. For 9, do we have before this 8 or 10? No, we doesn't have. So the subsequence will be 9 itself. And at 1, we need to check whether we have 0. The nums of I will be starting from 1. So we will not be having 0. So we need to check for 2. Are we having 2 before this element? No. So we move to the next element. At 3, we check whether we are having the previous element. So is there a 2 before this element? No, we doesn't have. And after this, do we have 4 previously? No, we doesn't have. So at 3, we are having 3, but the sum at 1 will be 1 itself. So sum of 1 is equal to 1. But when we come to here, the sum of 1 will increase to 2. And now we are at 3. And sum of 9 will be 9, and sum of 3 will be 3. And now, as there is no 2 or 4 previously before 3 has come, so we doesn't get any other subsequence. Now we are at 10. So we need to check whether we have element 11 or 9, the previous or the greater element previously. So we have 9 here. So 9 comma 10 is a subsequence. We can add to the 10. So we are having another subsequence 9 comma 10. So the absolute difference between these two is 1. So now initially the sum of 10 is 0, but now we are having 10 plus 10, 20 plus 9, 29. And now we are not having anything 11 previously before the 10 has come. Now we need to go to the 2. We need to check whether we are having 1 and whether we are having 3, previous element and the next element. So we are having 1 here, so 1 comma 2, this to make a subsequence, and then these two 1 comma 2 make another subsequence. And also, as 1 has completed, we need to check for 3. Yes, we have a 3 here, so 3 comma 2 will make another subsequence. So we doesn't have anything else here. And also we come to 8. Now we need to check whether we are having the next greater element and the previous element. We need to check for 7. Do we have 7 before 8 has come? No, we doesn't have. We need to check for 9. Do we have 9 before 8 has come? Yes, we have. 9 comma 8 is a subsequence. But for every step, for every element, we need to increment the sum of that element. Now sum of 2 initially is 0, but 2 for 4 times 8, and 2 times 1 is 2. 8 plus 2 10 plus 3 13. 13 is the sum for 2, and then we got 8. Initially the sum of 8 is 0. Now 8 to the 16 plus 9 25. So if we add all these, we get 27 29 25 81. So we get the sum of all the subsequences as 8. But the problem here is we don't know what are the subsequences do we have previously. That means for 2 we have 2 1s here, and also we have a 3 here, but we doesn't have any count which is telling us. So with this sum, we need to check whether we are having a previous element which is lesser or greater than that element. So 9, we need to maintain a DP array. This DP array will tell us how many times an element is before the current element, is recurring or present before this element. So if we are at 1, we are having DP of 1 is equal to 1, and then at second one we are having DP of 1 is equal to 2. Now with this help, we can say that we are getting 2 1s. With this help, we are getting 2 times 1 for the element lesser than 2. So this will eventually help us to find the sum, as the question only asked for sum. So we need to have 2. 2 is multiplied for 2 times the previous element. So if we take the current element as num, so as we are having 2, as I said, 2 is also a subsequence. We need to add that immediately to the sum of the num. So as I said, sum of 2 initially is 0, but when we get to the element which is 2, we need to add sum of 2 is equal to sum of 2 plus sum of nums of I if it is a 2. So the sum of num plus is equal to, sorry, here it will be 2. It will be num sum of 2 plus 2. If we get 2, if we get 2 here, we need to add that to the sum of 2. So as you can say that here we are getting 1 and then we are getting 1, so we added 1 and 1 and we got 2 as a sum, and this will reduce the first row sum to calculate another time. So this will make us simple. So here 9 is occurring for one time and 10 minus 1 is 9. So we need to store dp of 9 is equal to 1. Instead of calculating or using a recursion function to generate all the subsequence, we can simply use dp of 9 is equal to 1. So how many times will you add this to the sum? 1 into 2 times. So num, if 2 is num minus 1 into num times. So dp of the number of times it is recurring into the current num. So for this we have calculated dp of num minus 1, 9, dp of 9 is 1, so we are adding 8 for one time. Num into dp of num minus 1 is one time, and we are also adding 9 here. So this will eventually the sum of 9. So the sum of num will be initially sum of num plus is equal to num, and sum of num plus is equal to sum of num minus 1 plus dp of num minus 1 into num. As the same code we will be having as sum of num plus is equal to sum of num plus 1 plus dp of num plus 1 into num. So this is how we write the code, and don't forget to do the modulus operation for modulo operator for mod, that will be value of 1 is 7. So as the constraints are about 10 of 10 power 5, we need to consider modular operators with mod.